3 billion miles from where you are sitting right now, there is a world barely bigger than the distance across the United States, so far from the sun that noon on its surface looks like a deep twilight on Earth. And scientists just found out it is running a climate system that exists nowhere else in the entire solar system. Not a smaller, colder version of something familiar. Something genuinely new, a mechanism nobody had ever documented on any planet, moon, or dwarf planet before, hiding in plain sight in a hazy blue sky that has been photographed for years without anyone fully understanding what it was actually doing. And that is not even the strangest thing the James Webb Space Telescope has found there. Buried inside Pluto's infrared spectrum is a signal that does not match any molecule ever cataloged by human science. Not once, not anywhere. Not on any planet, moon, comet, or laboratory sample ever analyzed. The same unidentified signal has now turned up on a completely different world, 67 light minutes away, orbiting a different planet entirely. Two worlds, no obvious reason to share anything in common, and the exact same unexplained chemical fingerprint sitting in both of their skies. This is the story of what Webb actually found at Pluto, and why the dwarf planet, demoted from full planetary status in 2006, has quietly become one of the most scientifically interesting places in the entire solar system. I am your name, and this is your channel. Subscribe now if you want more stories like this, because we are just getting started. To understand why any of this matters, you have to understand what most people still assume about Pluto, an assumption that even professional astronomers held until surprisingly recently. For most of the 20th century, Pluto was treated as a frozen, static, essentially dead world, a tiny ball of ice sitting at the outer edge of what astronomers considered the properly organized solar system, demoted from full planet status in 2006, specifically because it seemed to belong to a much larger and less remarkable population of icy Kuiper Belt objects, rather than standing apart as something special. Then, on July 14, 2015, NASA's New Horizons spacecraft skimmed, just 7,800 miles above Pluto's surface after a 9-year journey across the solar system, and every assumption about a frozen, geologically dead world collapsed within hours of the first images coming back. Pluto turned out to have towering mountains of water ice, vast plains of nitrogen ice smooth enough to suggest they had been resurfaced recently rather than sitting untouched for billions of years, and a massive, pale, heart-shaped basin named Sputnik Planitia that appeared to be actively evolving. Pluto, it turned out, was not a dead relic. It was an active world, and nobody had expected that from something so small, so cold, and so far from the sun's warmth. The mission also revealed a chemically rich atmosphere containing nitrogen, methane, and carbon monoxide. Layered structure visible even in the thin haze that stretched for miles above the surface, and evidence that material was somehow cycling between Pluto and its surprisingly large companion moon, Charon, an interaction between a dwarf planet and its moon unlike anything previously documented anywhere else in the solar system. That discovery set the stage for what the James Webb Space Telescope would eventually find. Because New Horizons could only look, it could not linger. It flew past Pluto once, gathered as much data as possible during a brief flyby window, and continued onward into deeper space, leaving behind more questions than it could ever answer with a single pass. The spacecraft's cameras and instruments worked at extraordinary speed during those few critical hours, capturing everything they could before Pluto shrank back into a distant point of light behind them. And scientists spent years afterwards slowly downloading and analyzing the full dataset, discovering new details in old images long after the flyby itself had ended. One of the biggest of those questions involved something New Horizons had photographed clearly but never fully explained. A thin, hazy blue layer wrapped around Pluto's upper atmosphere, visible in some of the mission's most famous images as a delicate glowing ring backlit by the distant sun. Scientists had documented that the haze existed. They had not been able to explain what it was actually doing to the rest of Pluto's atmosphere, because doing that required an instrument far more sensitive to infrared light than anything available at the time, one capable of separating Pluto's extremely faint thermal glow from the glow of its unusually large moon Charon, orbiting close enough that the two bodies' signals blur together from Earth's perspective. That is exactly the problem the James Webb Space Telescope was finally built to solve. Back in 2017, a planetary scientist named Shi Zhang at the University of California sent a colleagues considered, in his own words, a little bit crazy. He suggested that the haze particles drifting through Pluto's upper atmosphere were not just a visual curiosity, they were actually running the entire show, controlling the dwarf planet's energy balance directly, in a way no other atmosphere in the solar system relies on. His theory proposed that these microscopic organic particles, formed when sunlight breaks apart methane and nitrogen molecules high in Pluto's atmosphere, absorb solar energy during Pluto's long day, and then release that energy back out as infrared radiation once night falls, acting essentially like a natural air conditioning system for the entire upper atmosphere. If Zhang was right, the haze itself should be glowing brightly in specific mid-infrared wavelengths, a signal no telescope existing in 2017 was sensitive enough to detect. He made the prediction anyway, and then waited for an instrument capable of actually testing it. When Webb's results finally confirmed the prediction 8 years later, Zhang described the moment with visible relief rather than pure scientific detachment. In planetary science, he said afterward, "It's not common to have a hypothesis confirmed so quickly within just a few years, so we feel pretty lucky and very excited." What had once been dismissed by some of his own colleagues as an unlikely idea had turned into one of the more striking confirmed predictions in recent planetary science, precisely because Webb's instruments finally caught up to a theory that had been sitting untested for the better part of a decade. That instrument arrived when James Webb reached its observation post roughly 1,000,000 miles from Earth and pointed its mid-infrared instrument, known as MIRI, directly at the Pluto-Charon system. MIRI was specifically built to detect exactly this kind of extremely faint thermal signal, tuned to wavelengths between roughly 5 and 28 micrometers, a range where cold, distant objects glow most clearly, but one that had remained largely unusable for studying Pluto in fine detail until an instrument with Webb's combination of sensitivity and its 6.5-meter mirror finally became available. Using observations gathered starting in 2022, an international team led by Tanguy Bertrand of the Paris Observatory finally separated the extremely faint thermal signals of Pluto and Charon from each other for the first time, something no previous telescope had been sensitive enough to accomplish, capturing distinct light curves at wavelengths of 18, 21, and 25 micrometers. What came back matched Zhang's prediction almost exactly. Pluto's haze was indeed radiating a strong, unmistakable mid-infrared glow, direct physical confirmation that those particles really were absorbing sunlight by day and dumping that energy back into space by night, regulating the temperature of Pluto's entire upper atmosphere through a mechanism no other world in the solar system is known to rely on. The findings, published in the peer-reviewed journal Nature Astronomy on June 2, 2025, led Bertrand to describe what his team had found in strikingly simple terms. "This is unique in the solar system," he said. "It is a new kind of climate. The same, Charon, orbiting right alongside Pluto but behaving nothing like it. Charon, the data confirmed, has no meaningful atmosphere at all, and a much more uniform surface dominated by water ice mixed with ammonia-based compounds, its reddish polar regions colored by exactly the methane drifting over from Pluto that the haze had helped kick loose in the first place. Two worlds locked in a tight orbital dance around each other, one running an atmosphere built almost entirely around a mechanism found nowhere else, known to science, the other essentially airless, connected only by a slow trickle of escaping gas drifting from one to the other across the gap between them. A genuinely strange partnership between a dwarf planet and its oversized moon that exists nowhere else in the entire solar system. Here is why that discovery matters beyond simply being an interesting curiosity about a distant dwarf planet. On every other planetary atmosphere, astronomers have studied in detail, Earth included, the balance between incoming sunlight and outgoing heat is controlled primarily by gas molecules, the same greenhouse and cooling processes that regulate our own planet's climate. Pluto's atmosphere, astonishingly, runs on solid aerosol particles instead, an entirely different physical mechanism controlling the same fundamental process. On Earth, water vapor, carbon dioxide, and other gases absorb and re-emit infrared radiation directly, gas molecules doing the work of regulating temperature at a molecular level. On Pluto, that same job is being performed instead by tiny solid grains of organic material, drifting particles rather than gas, absorbing and releasing energy in a physical process closer to how smog or smoke behaves in Earth's own atmosphere than to any conventional greenhouse mechanism, yet somehow doing it with enough consistency and scale to control the temperature of an entire world. And the haze does more than just regulate temperature. Webb's data also confirmed the second half of Zhang's original theory that the same haze particles are directly responsible for one of Pluto's strangest and longest unexplained mysteries, why its thin atmosphere leaks methane into space at a rate of nearly 3 pounds every second, steadily bleeding away material that should, by simple physics, be too cold and too gravitationally weak to escape at all. The haze particles, heated by absorbed sunlight, transfer enough energy to nearby gas molecules to kick some of them entirely out of Pluto's gravitational grip, sending escaping methane drifting off into space, where a portion of it eventually settles onto the poles of Pluto's companion moon, Charon, staining them with the reddish tint visible in New Horizons imagery, an interaction between two worlds happening nowhere else in the solar system. Scientists studying the system have pointed out that understanding Pluto's haze-driven climate offers something unexpectedly valuable far closer to home. Earth's earliest atmosphere, billions of years before oxygen-producing life transformed it into what we breathe today, was dominated by nitrogen and a haze-forming mixture of hydrocarbons remarkably similar in basic chemistry to what currently surrounds Pluto. Some researchers have long suspected that a similar organic haze may have blanketed early Earth, shaping its climate and even shielding its surface from harmful ultraviolet radiation during the same period life was first beginning to take hold. Watching how Pluto's haze actually behaves in real time gives researchers a working laboratory, a genuine natural experiment for understanding the kind of atmospheric chemistry that may have shaped conditions on the young Earth long before anything resembling modern biology existed, a distant, frozen world unexpectedly offering a window into our own planet's deep, almost unrecognizable past. But the haze discovery, as significant as it turned out to be, is not the strangest thing Webb has found at Pluto. That distinction belongs to a signal so recent that the research describing it was only posted for scientific review this past June. A separate research team, digging back through archived Webb observations of Pluto originally gathered in May 2023, decided to focus specifically on a range of infrared wavelengths that most previous analysis had passed over, buried inside that unexplored slice of the spectrum. They found something nobody expected. A distinct, unmistakable absorption line centered at almost exactly 5.11 micrometers, a specific wavelength where light is being absorbed by something in Pluto's atmosphere or surface that does not match any molecule ever previously identified, not in any planetary atmosphere across the entire solar system, and not among any of the increasingly exotic atmospheres researchers have now cataloged on planets orbiting other stars. Entirely. The finding was strange enough that the team did not rush to publish a definitive claim. Instead, the study was posted to the preprint server Airarchive on June 11, 2026, a standard step researchers take to share early results with the wider scientific community for scrutiny before formal peer review, precisely because a claim this unusual demands as many independent eyes checking the data as possible before anyone commits to a firm conclusion. Researchers did not stop at Pluto. Because the discovery was strange enough to demand a second check, the same team went back through Webb's archived observations of a completely different world, Titan, Saturn's largest moon, sitting roughly 600 million miles farther from the Sun than Pluto and orbiting an entirely different planet. And there, in Titan's atmosphere, the exact same absorption signature turned up again, centered at almost precisely the same 5.11 micrometer wavelength. The signal was not identical in every detail. On Pluto, the absorption line was measured as roughly 3 times wider than the equivalent signal on Titan, even though both showed a similar overall depth, somewhere between 4 and 5%, a difference researchers believe may hold clues about how the responsible compound behaves differently under each world's specific temperature and pressure conditions. The extra width on Pluto could point toward differences in pressure broadening, temperature, or even the physical state of the compound, whether it exists as a gas, a solid ice, or some combination of the two on each world's very different atmosphere. But the core signature, the same specific wavelength, the same fundamental fingerprint, was undeniably present on both worlds. What makes this genuinely strange, rather than simply an unresolved technical curiosity, is how little Pluto and Titan actually have in common. Titan is a moon of Saturn, larger than the planet Mercury, wrapped in a thick, hazy nitrogen-methane atmosphere dense enough to support standing lakes and rivers of liquid methane and ethane on its surface. A genuinely alien world with weather, rainfall, and seasons of its own, despite sitting nearly 1 billion miles from the Sun. Pluto is a dwarf planet, dramatically smaller, with an atmosphere so thin it is measured in millionths of Earth's surface pressure, orbiting the Sun rather than a planet in a completely different region of the solar system, separated from Titan by hundreds of millions of miles and an entirely different formation history. There is no obvious shared history, no obvious shared formation process. Nothing that would automatically predict these two worlds should have anything chemically in common at all. Researchers went back through the scientific literature searching for any previously cataloged compound that might explain an absorption feature at this specific wavelength, checking known spectra for substances already confirmed to exist on both worlds, including ethane, ethylene, acetylene, propane, benzene, and hydrogen cyanide. According to the team's own published account, they did not find a single referenced absorption band anywhere in existing scientific literature that lined up with what they were actually seeing on either world. That kind of exhaustive negative result, checking every plausible known candidate and coming up empty every single time, is exactly what makes researchers confident this is not simply an overlooked footnote in some previous study, but a genuinely new detection that the broader scientific community has not yet identified or explained. That leaves researchers with a genuinely open mystery sitting in freshly analyzed Webb data, current as of this year. Either there is some shared chemical process linking Pluto and Titan that nobody has previously identified, something in how sunlight interacts with nitrogen and methane-based atmospheres at extreme distances from the sun that produces this exact signature under a specific range of conditions, or there's a compound present on both worlds that has simply never been cataloged in any laboratory spectrum human scientists have compiled so far, an entirely unidentified molecule sitting in plain sight in data Webb captured years ago, waiting for the right researchers to finally look at the right slice of the spectrum. Solving a mystery like this typically requires more than just re-examining existing telescope data. Laboratories on Earth may need to recreate the extreme cold and specific chemical mixtures believed to exist in Pluto's and Titan's atmospheres, testing candidate compounds directly under controlled conditions until one finally produces a matching absorption signature, a painstaking process that can take years even once researchers have a strong working hypothesis to test. Here is what deserves to sit at the center of this entire story. Pluto spent decades treated as the least interesting object in the solar system, demoted from planetary status, written off by much of the public as a frozen afterthought sitting at the edge of everything that actually mattered. New Horizons proved that assumption wrong in a single flyby in 2015, revealing mountains, glaciers, and active geology on a world nobody expected to be alive in any meaningful sense. Webb has now proven the same assumption wrong a second time, revealing a genuinely unique climate system running on haze particles. Instead of gas, an atmosphere that manufactures its own temperature regulation through a mechanism no other world is known to use, and, buried inside data gathered years ago, a chemical signature that does not match anything currently known to science, shared inexplicably with a completely different world orbiting a completely different planet. Because Pluto takes 248 Earth years to complete a single orbit around the Sun, the observations gathered so far by Webb capture only the very earliest stages of an Arctic winter, now settling over its northern hemisphere, a season that will continue slowly deepening for decades to come, far outlasting the career of any scientist currently studying it, with each new set of Webb observations offering another chance to watch that unique climate system respond to conditions no human before. The question left sitting at the center of all of this is simple, and nobody currently has an answer. What exactly is producing that 5.11 micrometer signal on 2? Worlds that should have almost nothing in common, and what will identifying it actually tell us about the chemistry quietly happening on cold, distant worlds all across the outer solar system that nobody has thought to look closely enough at yet? Pluto sits roughly 3 billion miles from Earth, so distant that sunlight itself takes over 5 hours to complete the journey. And for most of human history, it existed only as a faint, unresolved point of light, first photographed clearly only in 1930 and not properly imaged in detail until New Horizons arrived 85 years later. A gap of nearly a century between first spotting a smudge of light and finally seeing the actual world behind it. In the space of just over a decade since that flyby, a world once dismissed as a frozen afterthought has produced two of the most genuinely surprising discoveries in recent planetary science, an atmosphere that runs on a mechanism found nowhere else, and a chemical signature that matches nothing in any laboratory reference on Earth. Both discoveries arrived not from a dramatic new mission racing across the solar system, but from patient scientists returning again and again to data already sitting in Webb's archives, asking the kind of question that only gets answered when someone is stubborn enough to keep looking at a distant, quiet corner of the sky that everyone else assumed had already given up its secrets. If this kind of story is what you come here for, subscribe right now and turn on notifications, because we are going deeper into the edges of what science actually knows next time. Drop a comment with what surprised you most in this video, and share this with someone who needs to hear it, because this story deserves more than the silence it is getting.